In your module, you learned about calculating the resistance of a wire, and I want to work a few problems with you here. So we know that the wire itself has a few different properties. For instance, the length of the wire is important to note in our equation here, length, and the cross-sectional area. And remember, the area is pi r squared, so it's not, the area is not the diameter or the radius, it's actually pi times the radius squared. So be careful of that, because you're going to probably need to calculate the area before you can plug that into your equation. And then, of course, we have whatever the material is of whatever material the wire is made of, and we use rho to symbolize that. That's the resistivity of that material. For instance, for copper, the resistivity is about 10.37 circular milliohms per foot are the units of that. Okay, so our equation is rho times length over area will give us the resistance of our wire. And what that means is as we increase the resistivity of the material, we are increasing the resistance. If the length of the wire increases, we're again increasing the resistance, because the resistivity and the length are basically in the numerator of our fraction. However, if we increase the area, we're actually decreasing the resistance of the wire, and that kind of makes sense if you look at it like it's a pipe. If we make the pipe bigger, we can force the water through at a greater rate. Okay, so let's go back to our discussion of area. Area we're going to calculate in a slightly different way from what you're used to, and that is by squaring the circular mills. Now, the circular mills has something to do with that, that pi r squared that we talked about before. But in circular mills, we're going to calculate that using the mill squared. Okay, so basically all you need to understand about mills is that 1 inch is equal to 1,000 mils, or a mil is equal to 1/1000th of an inch. So if you're given the diameter of a wire in inches, you will convert it to mils, and then you will square it to get the area. So you need to do this step before you can do this step. Okay, so keep that in mind as we're working through these problems. Okay, so if the area of a wire is 820, and I'm going to make sure that equation is shown here. If the area of a wire is 820 circular mils, what is the diameter? And we want that in inches. Okay, so you're looking for the diameter. So whenever you're reading word problems, make sure you're looking for, find what is it I'm looking for, what is it that I'm given, okay, given. Okay, so A is 820 circular mils, and I need to look for D. But remember, area is the diameter in mils squared. So if I take the square root of 820 and the square root of D squared, I get the area in mils, which is 28.64 mils. But remember, they asked me for inches, so I'm going to have to do a conversion. Now, There's a way of doing conversions if you're not quite sure whether to multiply or divide. Look at the units, right? We want to get inches from mils, okay? So what I like to do is start out with what I have, 28.64 mils. And then I'm going to draw this little fraction and convert my units. So I know that I have 1,000 mils in 1 inch. So that's going to be my conversion factor. So I'm going to put 1,000 mils on the bottom, because when I divide mils by mils, the units cancel out. And I put 1 inch on the top because that's going to leave me with inches when I'm finished. So 28.64 divided by 1,000. Or if we want to round, oops. And there's our inches. Okay. We're going to do the next problem in exactly the same way. The area is 6.25 circular mils, and that is d squared, where d is in mils. So if we take the square root of 6.25 circular mils, we get 2.5 mils. Again, we are asked for inches. So 1 inch over 1,000 mils. So the diameter is 0.0025 inches. And notice when I finish working a problem, I'm going to kind of box it at the end to make sure that we see that that is indeed the answer. Now that was all working on step 1. Now let's apply that to step 2 and actually create calculate the resistance of an actual wire. So again, we want to start by looking at all the information we're given. So what is the resistance? What is the resistance? So we're looking for the resistance of 100 feet of copper wire. What is 100 feet? That's the length. And what else are we told? Copper wire, okay? Because copper has a resistivity of 10.37. So that means the resistivity we're given, let me clean that up a little bit. The resistivity is 10.37 circular milliohms per foot, with a diameter of 0.2 inches. Now that's not the area, okay? That's the diameter. And it's in inches, which we're going to have to work with as well. So we have 2 components of our equation. We need the area though. So I'm going to pull the diameter over here and note that area equals diameter squared, but they have to be in mils. So the first thing we're going to do is convert our 0.02 inches to mils. So we know we have 1,000 mils in an inch. So I'm using the opposite conversion factor from what we used up here, because we were converting from mils to inches, and now we're converting from inches to mils. So I want my inches units to cancel out. So what we have here is 20 mils, and if the area is d squared in mils, that means that we have 400 circular mils. And there's our area. So we now have all three components that we need to calculate our resistance. Because remember, resistance is equal to the resistivity times the length over the area. So now we just plug these numbers in since they are all in the right units. Now, another thing we like to do when you're working these equations in engineering, if you can work on canceling out your units and make sure that your answer is in the right units, you'll have a lot more confidence in your actual answer. So let's point out here that we have circular mils on the top, circular mils on the bottom. We have feet on the top, and then this is divided by feet, so that's actually going to cancel that out. So our answer is actually going to be in ohms, which is actually resistance, the unit of resistance. So when we multiply 10.37 by 100 and then divide by 400, we get 2.59 ohms. And that is the resistance of 100 feet of copper wire with a diameter of 0.02 inches. Let's work another problem. We have a 2.2 ohm resistor. Okay, again, go ahead and figure out what you're given. We're given that the resistance is 2.2 ohms. So we're not calculating the resistance this time. We're calculating something else. 2.2 ohms is made of nickel chromium wire, nichrome wire. And nickel chromium wire let's see, what is the table in your book says nickel chromium wire has a resistivity of 600 circular mil ohms per foot. So I looked that up. If you need one of the resistivity numbers, like on a test, I will give that to you, but there is a table in your book and you can look that up as well. The available wire is 1/32 inches in diameter. So we have the diameter, and we're asked how much wire is required, or the length. Okay, so we have resistivity is about 600 circular mil ohms per foot. Again, I got this from the table in the book. Okay, so if you're wondering where that came from. And then we know the diameter is 1/32 of an inch. We're going to have to do something with that because we need the area in our equation, and we're looking for the length. So a couple things. First of all, we need to find area, and then we need to solve for the length. Okay, so let's find the area first. Remember, our diameter needs to be in mils. So we have 1,000 mils in 1 inch. So we've got 31.25 mils there. And the area is going to be mils squared. So that gives us about 976.56 circular mils. Okay, now solve for, so we did this. Now solve for the length. Let's write our equation here. So rho times length over area. let's go ahead and solve for the length in this equation using a little bit of algebra. Now remember, algebra, as long as we do the same thing to both sides, we can do pretty much anything we want. So the first thing I like to do when I have a fraction is to multiply both sides by the denominator to get rid of the fraction. So I'm going to multiply both sides by the area. So it cancels out on the right hand side, and I'm left with A times R and rho times length. Now I'm looking for length, right? So I'm trying to get length all by itself on one side. So what I'm going to do is divide both sides by the resistivity. So the resistivity cancels out here, and I'm left with length. So here's my new equation, and I'm going to switch sides just to put the length on the left side and the equation on the right. Actually, my rho looks a little bit like an L, so I want to make sure that it doesn't. Okay, now I'm going to just plug in. I've got my area right here. I've got my resistance I was given in the beginning, and then my resistivity. And if you do, if you look at the units again, we've got circular mils on the top and on the bottom. We've got ohms on the top and on the bottom, and then on the bottom we're dividing by feet, which means that's going to actually be the units of our solution. So what we get is about 3.58 feet of copper wire is what we need to have a resistance of 2.2 ohms if this is our diameter of that. I'm sorry if I said copper wire, that's nickel chromium wire. Okay, if we were looking for the amount of copper wire here to give the same resistance, we would need to change the resistivity down to that 10.37 number, and it would probably require a great deal more wire for that. All right, so let's look at our next problem here. A wire is 1,000 feet long, has a resistance of 0.5 K ohms, remember that's thousands, and an area of 94 circular mils. What material is the wire made of? Oh, this is interesting. So again, we've got a length of 1,000 feet. We have a resistance that is given as 0.5 kiloohms, and we have an area of 94 circular mils. And we need to find the material the wire is made of. Well, remember that's resistivity. Okay, that's where we put in the influence of that material. So, and I even gave you that hint here. So how would we solve for the resistivity in our equation? Well, let's use a little bit of algebra to do this again, and just keep working on those algebra skills if this is a little bit difficult for you. Again, I'm going to start by getting rid of my fraction, so I'm going to multiply both sides by the area. And to get rho all by itself, I'm going to now divide by the length. So resistivity is going to be area times resistance divided by length. So let's plug in our numbers. So we have 94 circular mils. Resistance is 0.5 kiloohms. If you wanted to, you could just write that as 500 ohms, but whatever you do, or remember that's 0.5 times 10 to the third. So you need to either put in the power of 10 or convert it to standard form before you go any further. Divided by the length, and it looks like we have about 47 circular mill ohms per foot. And if we look at our table in our book, it appears that that represents nickel. So we must have nickel wire there. All right, so let's look at one more thing and then we'll move on. Actually, that problem number is wrong. There's another way to find the resistance of a wire, and I want to show you that. There's actually something called the American Wire Gauge Table, and if you look in your book, you will see that in Chapter 3, the AWG table. In the table, and we're going to use this problem up here, number 3. If we want to calculate the resistance of 100 feet of copper wire with a diameter of 0.02. So let me write that in. We have 100 feet of copper wire, and I actually gave you the gauge. The gauge actually refers to the diameter, but in your book, I think it's 100 feet of copper wire is the length. In your table, 24 gauge copper wire has a resistance of 25.67 ohms per 1,000 feet. Okay, that's what you get from the table, is you get the resistance per 1,000 feet. So if we have 100 feet of wire, what we would do is say, okay, we've got 25.67 ohms for every 1,000 feet of wire, and we're going to multiply that by the actual length of wire we have. So when we do that, we actually find that the resistance of this wire would be about 2.57 ohms. And let's go see, what did we find when we calculated it outright? About 2.59, so it was pretty close. So if you want to take a look at that American Wire Gauge table, go ahead and do that. That is just another way, and that's really the quicker way that we would probably calculate the resistance of a wire, given that it's a copper wire, that it's a single strand, and that we know the gauge of the wire. This is a lot quicker way to calculate that. So go back over this video if you need to practice with this again, and we'll move on to reading resistors next.